Hi, Dr. Shmaila here, your mentor and physiotherapist. Today we start with chapter number 2 of kinesiology, that is an introduction to movement. Now let's start with it. Movement is fundamental characteristics of all animal and mean by which organism adapt itself to the demands made by environment in which it lives. The human body was made for movement. Every day you move different part of your body from your head to toes. All bodies move differently. Even picking up a book and turning the pages involve moving your body. Have you ever wondered how your body moves? Think about it. Moving an arm or leg might seem like a simple task, but human movement is actually very complex. Movement is a change in place, position, or posture in relation to the environment. So, to sum up, we can say movement is a change in place, position, or posture in relation to the environment. Movement happens only when the different body systems such as skeletal system, cardiovascular system, neuromuscular system and body's energy system work together to move successfully. These systems interact and adapt to a constantly changing environment. Body levers. Bones form the arms or rigid bars of the levers, and fulcrum is at a joint where the movement takes place. The structure of a joint is related to its function and determine the type of movement possible. It is interesting to note that the shape and direction of the articular surface is such that normal functional movement is rarely unidirectional in character. No lever is functional unless some force is applied to it. No, uh, we look at the type of the forces acting on the body levers. Force divided in two types: external, internal. External force source outside, either gravity or physiotherapist hand, and the internal force is applied by the muscle contraction. External force under gravity and the action towards our center, and internal force that is applied by muscle contraction, the action towards muscle pull. Pull is in the direction of the muscle attachment. Now look at the type of the movements: passive movement, active movement. Passive movement, application of the external force. Active movements by the contraction of the muscle. Passive means by outside source, external force. It may be your opposite hand, opposite extremity. It may be your physiotherapist. While the active movement, in active movement, basically your muscles are contracting and performing movement. Um, in active movement basically patient can perform itself, but passive movement are performed outside because patient muscles are weak and unable to perform these type of the movements. Now look at the type of the muscle contraction. Muscle contraction and tension divided into two types: isometric and isotonic. Isotonic further divided into two types: concentric and eccentric. Now look at their definition. Isometric. Look at this. Muscle contracts but does not shorten because there is no movement. But mm, muscle contracts. Isometric, iso equal and metric measurement. Contraction, basically isometric contraction, we can say involves the development of the force by increasing intramuscular tension without any change in the length of the muscle, while in isotonic contraction constitute an increase in the intramuscular tension accompanied by the change in the length of the muscle. The change in the length may either shorten or lengthen the muscle. No, type of the muscle work. First of all, we define work. What is work? Work is defined as the product of the force and distance through which the force acts. The type of muscle work used in controlling and moving the body levers may be static, concentric, or eccentric. Static muscle work. The muscle contract isometrically to counterbalance opposing forces and maintain stability, but as there is no movement, no work is done. Nevertheless, this type of the muscle activity is usually inaccurately called static muscle work to distinguish it from concentric and eccentric muscle work. Concentric muscle work. The muscles contract isotonically in shortening. Concentric means shortening position in muscles contracting. The muscle shorten. So we can say muscle contract isotonically in shortening to produce movement. The attachment of the muscles are drawn close together. Basically, concentric means towards shortening towards the center, and movement is in the direction of the muscle pull. And what is eccentric muscle work or eccentric muscle work? The muscle contract isotonically in lengthening. The muscle attachments are drawn apart. Eccentric means away from the center, as it works to oppose the action of the force which is greater than that of its own contraction. Movement is therefore in the direction of the opposing force, that is in the direction opposite that of the muscle pull. Hopefully you understand what type of movement, type of the forces, type of the muscle contraction, and type of the muscle work. Now look at the range of the muscle work. Range. What is the range of full range? Full range in which muscle work refers to a muscle changing from a position of full stretch and contracting to a position of maximum shortening. For example, in case of elbow flexion extension, we can say when your elbow is straight and your arm is straight, and that position, start from that position and move the your elbow in shortened position, touching the shoulder. That is the range. Full range is further divided into uh, three parts: outer, inner, and middle range. No, look at their definition. Outer range is from a position where the muscle is on full stretch to position halfway through the full range of the motion. Inner range is the from a position halfway through the full range to position where the muscle is fully shortened. And middle range is the portion of the full range between the midpoint of the outer range and the midpoint of the inner range. Look at this diagram. Elbow flexion extension, as you know, action elbow flexion is performed by the bicep and elbow extension is performed by the tricep. Full range, this is the full range for bicep and tricep. Now middle range, bicep and tricep. B is marked middle range. This is the middle range. And if you look at the C, inner range, now look at C line. That C line basically inner range. Inner range is for bicep, and out it is the basically outer range for tricep. And D mark D in which inner range, it is the inner range of tricep, because tricep muscle action is elbow extension, and this is its inner range, and it is outer range for bicep. Hopefully you got it. Now further we continue. Strength of the muscle. You know, strength of the muscle is the muscle's ability to generate tension, and the strength of the muscle contraction varies in proportion to the tension exerted by the forces which oppose in action. Variation in the strength of the muscle contraction is made possible by means of system of motor unit. Now, what is motor unit. A motor unit consists of a single neuron and the group of the muscle fibers it supplies. When unit is activated by stimulation of a cell, what cells, and neuron cells, we can say all its component fibers contract. As each muscle is made up of, from the fibers of a considerable number of the motor unit, the strength of the contraction of the muscle as a whole is largely dependent upon the number of its motor unit activated at one time. Greater the number of the motor unit activated, the stronger the contraction of the muscle as a whole. Thus, a weak contraction requires the activity of only relatively few motor units. But strong contraction, the muscle can produce a maximum contraction is only obtained when the fibers of the all available motor unit are contracting. So we can say that basically it is the number of motor unit activated basically in which strength of the contraction depends. Greater the number of motor unit activated, stronger the contraction of the muscle, and if fewer motor unit activated, obviously then there is weak contraction. This is all about strength of the muscle contraction and motor unit. What is group action of the muscles? Prime movers bring about the desired movement. We can say these are the basically agonists. Antagonists or opponents produce movement opposite to the prime mover. They help the prime mover by active controlled relaxation. Fixators, basically fixators, stabilize the region of the prime mover so it can work efficiently. Synergists, when the prime mover cross more than one joint on desired action at you can say proximal joints are prevented by the certain muscles known as synergists. Now look at this example. So elbow by flexion, then here bicep brachii and brachialis muscle working together as prime movers. Obviously brachioradialis. Tricep muscle is their function is elbow extension and working as antagonist. Basically it is working to relax the arm, and here you can see that fixator deltoid fibers act as a fixator, and to basically they stabilize the arm. And synergists, in this case synergists are basically pronator teres. They basically they they prevent undesired action of the certain muscles. Pattern of movement. Sight and direction of the movement are described as a pattern, and wide variety of patterns are possible. Most functional movement patterns require movement in several joints, that is, mass movement, and observation of these patterns in everyday activities both interesting and instructive. Movements which are localized to few or a single joint are developed or distinct from mass movement pattern by a conscious process of learning. Now look at rhythm, timing, and duration of the movement. What is rhythm of movement? Word rhythm means a regular beat or reoccurrence of a sequence of events. The inspiratory muscles and the heart muscles contract rhythmically throughout the life, as you know, because it is impossible for life to sustain without these muscles. So, their period of contraction alternating with the period of relaxation and inaction. Skeletal muscles can also work for long periods of time without fatigue, providing that their contraction alternates regularly with complete relaxation and consequent replenishment of the blood supply, bringing oxygen to repair the effect of the contraction and to remove metabolic waste products. Rhythm of the work and rest reduces fatigue to the minimum. For example, a hiker walking with an even stride rhythmically contracts and relaxes the extensor muscles of the legs. A newcomer to the industry is trained in the rhythmical sequence of the movement he is to perform at work. If we look at movement, each movement has its own natural rhythm, which varies to some extent in individuals and according to their anatomical and physiological peculiarities. Natural rhythms also varies with age. Rhythm of the children's movement being relatively obviously quick as compared with that of the adult, while that of the very elderly is slower still. Rhythmical movements taken too quickly or too slowly usually results in faulty timing and loss of efficiency, an increase in the muscle work or a diminution of range of movement. So, uh, there is an optimal or natural rhythm for every movement to take place, and if rhythm of movement quick or slow from this level, then it results in faulty timing, loss of efficiency, obviously an increase in muscle effort and range of motion diminishes. Music plays at a suitable speed can assist the performance of movement. Popular tones with a definite beat and which are easily learned and remembered seem to be the most satisfactory as they reduce the burden of the repeated movements such as marching, typing, or scrubbing, etc. This is the rhythm of the movement. No, what is the timing in movement? Timing is the sequence of muscle contraction which take place in the production of movement. To be satisfactory, the force of each contraction is timed so that it is at its maximum when a subsequent force is superimposed upon it. Otherwise, the peak of effort reached will be wasted. There is a waste of effort if the timing is too slow or too fast. Faulty time frequently accounts for inefficiency of the movement for the purpose for which was designed. Some component may be omitted, either added, or the sequence is too slow or fast. For example, as learning to swim or play golf. So, if we in these activities we follow a natural time, then obviously it is helpful. And if time is faulty, that means if it is too slow or fast, then obviously there is a waste of effort. The timing of the functional movement usually proceeds from distal to proximal because it is the distal areas which receive most of the stimulus which control the movement. For example, distal areas, hands and your feet. The smooth and orderly sequence of the events which constitute effective timing ensures the maximum efficiency of muscle contraction, which is characteristics of the coordinated movement. Basically, movement, it is the characteristics of movement that movement must be smooth and orderly sequence of events, otherwise there is waste of effort. What is the duration of the movement? Duration of movement when exercise or treatment is the time that it lasts. An increase in the duration of the particular movements result in reduction of the speed, obviously, and this affects the amount of the muscle effort which is required to perform the movement, and a decrease in the duration of a similar movement result in an increase in the speed at which is performed. The duration of exercise usually indicates the time during which it is performed at any convenient speed, but we may also specify the number of times the exercise is performed. Treatment vary in duration according to the nature of the lesions, capacity of the patients, and the time available. Now is control of the movement. Motor unit is the functional unit of the neuromuscular system which initiate and achieve movement in response to the demand for activity. Unit's muscle fibers contract in response to the impulses discharged from its cells when it is stimulated. Anti-horn cells are influenced by the impulses which reach them from many sources in the CNS and other parts of the body. Some of these impulses are excitatory and others inhibitory, and is the predominance of one or the type at any one time which determines the effect they have on AHCs, anti-horn cells. The pattern of movement is planned in the initiating areas which also discharge the impulses to bring about this effect. Now, what is voluntary movement? Voluntary movement is initiated in response to a conscious effort to perform the movement that are under one's control, and reflex movements initiated in response to demands made by the sensory stimulation. Flex movement is basically involuntary, not under our control. Basically, it is occurs in response to the demand made by the sensory stimulation. Look at this diagram. Basically, if we look at the nervous control of the movement, we can say the sensory neurons which carry the information towards the spinal cord and brain, and the motor neuron, the descending pathways basically, which carries the information from spinal cord to the muscle, and muscle perform their action. This is all end of the chapter 2, and hopefully you like it very much. Thank you.